Hello everyone, I am Anshika and today we will be looking at another question, that is question number 367, valid perfect square. So first we'll be understanding what the question is, then we'll be looking at its possible solution, and then we'll come back on the Leetcode platform to solve this in the form of our code. So let's begin by reading the question. Given a positive integer num, return true if num is a perfect square or false otherwise. A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. And a note is given that you must not use any built-in library function such as square root. In the first example, we have num is equals to 16 and the output is true because we have two numbers, that is 4 times 4, that gives 16, and 4 is an integer. So that's why we have the output as true. The second number is 14 and the output is false because although there is a number that when multiplied by itself gives 14, but it's not an integer, that is 3.742. Then we have the constraints of num's value that lies between 1 to 2 raised to the power 31 minus 1. And this is our function that we have to complete, that is of Boolean return type and tells whether a particular integer num is a perfect square or not. Now let us look at the logic building and then the pseudocode of the solution. So first of all, let us understand what a perfect square is. A perfect square number is something over here num. For example, if we take 16 that was given in the previous example, is that there has to have be a number that could be multiplied by itself, that is n times n, and then it should result in 16. So we know that 4 times 4 is 16, and also we have 36. So if there is supposed to be a number that gives 36 on multiplying by itself, so here in this case that is 6 because 6 times 6 is 36. Similarly, 81 and all the perfect square numbers, for example, we have 4, sorry, 4, and then we have 9, then we have 25, and before that we have 16 as well, and then and so on, and the list goes on. So a perfect square number is such that there has to be a number that when multiplied by itself leads to that number. So in that case, if there is a number such that when it is multiplied by itself and then leads to a number, in that case the perfect square exists. So we have to return true. Or else, if the condition is not met, if we do not find any integers that when multiplied by themselves gives the particular num, so we return false. So let's formulate this into a pseudocode basically. Let me just clear this. Yeah. So when I come here, so first of all, one more thing is that about a perfect square number is that all the perfect squares are positive. Squares are positive numbers and they cannot be 0 or negative, right? Because they start from, we have 4 and then we have 9, 16 and 25 and so on. But none of them, even for a negative n, -2 or -3, they still give a positive number. right? Hence, the perfect square number cannot be 0 or negative. For that matter, we can summarize this and write as num, which is given here as our perfect square number that we have to check. If it is, then num should always be greater than 1, right? This is my, uh, wait a second. It can never be less than 1. It has to be, it has to be always in the positive direction. So there's that, and this is where our base case is going to be. This is what's our base case is. So first of all, let's write our function that we have to complete. So it's given as is perfect square, and we pass the integer of num in this, and it is obviously a Boolean return type. So first of all, we have to return false for this case. So if our num is less than 1, so obviously that number cannot be a perfect square because our perfect square numbers are not 0 or negative. So here we're going to return false simply. After that, we need to check if our basically any if there is any number I, suppose, such that when it is multiplied it leads to num. And if this is true, if we do find any number I, any integer I, such that when it's multiplied by itself leads to num, in that case we return true, because obviously only in that case our num is going to be a perfect square. Now, starting from this was the case for less than 1. Now, what about numbers that are starting from 1 and goes on? So, for those numbers, we use a for loop that is I equals to 1, as it starts from 1, as we have already checked till 1. It starts from 1 and it goes up to such that their multiplication leads to num. Okay? Actually, it should be lesser than or equal to num. Actually, it should be lesser than or equal to num. And also, then we increase our condition plus plus I. So this will come under our for loop. And also, I will be of long type because we don't want our number to our function to overflow, and that's why instead of using integer return type we use a long, because we in this condition we are multiplying I by itself, and what if I is itself a bigger number and then it is multiplied by itself and that value is bigger than what integer can store, so that's why we're using long. And over here we're doing plus plus I because we need to check for each and every number. As in when we are starting from 1, 1 times 1 is 1. And suppose our number is 16, okay? Our num is 16. And over here, since we have checked for 1, then we have to increment because 1 times 1 is 1 and it is lesser than 16. It's still not equal to. So yeah, this is true. Then sorry, we increment our value to 2. So that 2 times 2 we can check. It's 4 and 4 is less than 16. And then we have to increment it again. 3 times 3 is 9. That is also less than 16. So we move. Then 4 times 4. And this is 16. So it is equal to 16 that we were looking for. And hence, since this condition turns out to be true, our function will return true. So yeah, that was all. And after the for loop, we're going to mention return false. Let me just write it a bit over here. Yeah. Over here, we're going to return false because if we do not find any number, so automatically we have to come towards this and this statement will be executed and our function will return false if there is no number I that can eventually lead to num on multiplying by itself. So yeah, this was the whole concept. Now let's formulate this on the Leetcode platform. Okay, so here we are with our question. So let's first type in our base case. If num is less than 1, in that case we already know that it cannot be a perfect square, so we'll return false simply. After that, we are going to implement our for loop with the long I starting from 1 and I times I less than equal to num, and then we increment our value of I. And inside this, we're going to check for our case. If I times I is equal to num exactly, then we return true. And outside the for loop, if we do not find any number such that, then we return false. So simple. Now let's run this. Yep, it got accepted for both the examples or test cases, you must say. Now let's submit it. Here we go. We have solved this easy question. So thank you so much for watching.